Hey guys, like I promised in the previous video, in this video we'll be building our first artificial neural network using TensorFlow 2. But before I jump into the code, I'd first like to explain to you guys what TensorFlow is and how it works. Now TensorFlow 2 is a symbolic math library developed by engineers working on the Google Brain team, and this library will make it easier for us to build deep learning models like neural networks. TensorFlow is a Python library in the sense that it uses the Python programming language as a convenient API in the front end for building these deep learning models. However, the computations and math operations that TensorFlow runs are not executed in Python, but rather through high-performance C++ libraries. Python just provides a high-level abstraction that makes it easier for us to work with TensorFlow. That being said, you will not need to know any C++ to follow these videos, and all the code you'll see will most likely be in Python, so I do expect you guys to have at least a basic understanding of the Python programming language. Great, we've defined what TensorFlow is, so let's talk a little bit about how it works. If you recall, in the previous video we discussed the structure of a neural network, and it looked something like this. TensorFlow helps us describe this structure in code. The TensorFlow library has Python objects that we piece together to build our neural networks. These Python objects help us describe the structure of our neural networks and how data will flow through them. We can think of the neural net as a graph or a series of processing nodes, with each node in this graph representing a mathematical operation that will be performed on the data that flows through it. The connections between the nodes are multidimensional arrays of data or tensors. Now if you're finding it a bit difficult to wrap your head around this, don't worry about that. It'll get a bit clearer as we build our neural network. You really don't need to worry about the low-level implementations of TensorFlow. I just thought covering them might help you guys get a clearer picture of how all of this works. Enough about the theory though, let's jump into the code. Okay, now the text editor I'm using here is Atom. You can use any text editor you want, but if you want to use Atom, I'll leave a link to the download page in the video description. Now I've created here a file named ann.py, and below here I have the image of the neural network model we'll be building. So the first thing I'm going to do is import TensorFlow, and the code to do that is import TensorFlow as TF. And what this line of code will do is bring in the TensorFlow library into my file. The next thing I'm going to do is from TensorFlow dot keras dot layers, I'm going to import dense and activation, and we're going to need these to build our model. Now that I have the TensorFlow library imported, I'm going to build our TensorFlow model, which I'm going to name model. And I'm going to set this equal to tf dot keras dot models dot sequential. And this is an object that takes an array to its constructor. The TF here is referring to the TensorFlow library we imported. And TensorFlow 2 comes with Keras installed. And Keras is a high-level neural network library placed on top of TensorFlow, and it gives us another layer of abstraction to allow for fast prototyping. Now inside Keras we're reaching for models.sequential, and a sequential model is just a linear stack of layers, and this object just takes an array of layers to its constructor. Now we'll add the layers to our sequential object to build our model. Now the first layer I'll add is a dense layer with 5 neurons and an input shape of 3. And this layer will have an activation function of relu. We'll discuss activation functions at a later video. For now, think of it as a function that performs some kind of transformation on the data that the neurons in its layer will receive. We use the dense object to define our layer because for this model, the neurons in each layer are fully connected to the neurons in the next layer, and dense layers in a neural network are fully connected layers. We'll discuss other types of layers in future videos. Now if you look at our image, the layer with 5 neurons is layer 2 and not layer 1. But in the code for our first layer, we added 5 neurons. This is because the neurons in the input layer are defined in the input shape, which for this model it's 3. We'll then define our output layer as a dense layer with 3 neurons and an activation function of softmax. Again, we'll talk more about activation functions at a later video. But most of these layers will have activation functions and they do not necessarily have to be the same function. With that done, we have built our first artificial neural network and we are ready to compile it. Now for this, we'll be using Anaconda prompt. The first thing I'll do is to navigate to our project folder. So I'll type cd and the path to the folder. Use the path where your file is stored here. Then I'll change my Python environment to YouTube, which is where I have TensorFlow installed. So I'll run conda activate YouTube. Alright, with the environment changed, I'll run python ann.py to compile my model. Now this might take a while to compile and you will not have any output because our file prints nothing to the console. And if you're seeing errors related to the GPU and you're using the CPU version of TensorFlow, you can ignore them. Great, now we've built and compiled our first neural network. If you found this video helpful, leave a thumbs up and subscribe, and I'll see you in the next video.